Okay, good morning class. Okay, welcome back after the holiday. Basically, as you guys are well aware of the fact that the first term was a bit short, as well as we haven't covered the work for the first term. Okay, at this point we should have been well into the topic on trigonometry. So we should have had a week on trigonometry, and we should have completed Euclidean geometry. Okay, so we are basically behind. Okay, so what we've done thus far is, I've seen you guys have struggled with parts of factorization, with stuff like that. That is why we took extra time with it. Okay, but if we are not going to pick up the pace, we are not going to finish the work for the year. Okay, so that said, we have to just pick it up and finish as far as we can. Okay. Yes. Huh?
I'm coming to you.
How can you come to my class? And Miss Dixon? She must yes. Huh? Okay, have a seat. Okay. So yes, at this point we are busy with, we need to wrap up our equations and inequalities. As I said, we are going to finish a bit more than we usually do now. Okay? Please feel free to stop me and tell me you don't understand or whatever. Okay? So at this point we are busy with equations and inequalities. We're up until exercise. We got up until exercise. Sorry? 4.5. Did you guys have homework on 4.5? No. Okay, so your heading for today is simultaneous equations. Now, simultaneous equations, there's two ways of doing simultaneous equations. There's the elimination method and there's the substitution method. Okay, because of time constraints, I'm going to do the substitution method only. The reason for that is because the substitution method is done in grade 11 and 12. Okay, so I'm going straight into the substitution method there. Okay. Okay, that's on page 89. Okay, so on page 89, it's actually 85. We are told that using graphs to solve a system of equations can give approximate answers. Now, last year we've dealt with straight line graphs, you remember? Then we spoke about the point that the two graphs intersect. Okay? And that is also the point on the graph where the two graphs are basically equal to each other. Okay? Using substitution to solve a system of equations can be tedious and time consuming. So imagine now every time they give us equations and we must draw the graph and then determine that point at which the graphs intersect graphically. Now the downfall to that is if the graph is not drawn to scale, if your scale is out a bit, then it could be that your point of intersection is out. You guys understand? However, if you do it algebraically, it's more precise. Okay, this is the accurate answer. You guys understand? And besides that, drawing the graph every time is time consuming. Okay, do you guys understand? So we're going to look at two methods of solving the simultaneous linear equations. As I said, we're going to delve in the one method only. Why? Because of time constraint. The method applies to a system in two or more unknowns. Okay. As I said, you've dealt with simultaneous equations last year as well, not so? Now last year we've dealt with equations, two equations. However, the one equation had one unknown, so you needed to solve that first, not so? And then come back and solve the other unknown value. Here we are given an equation with two unknowns from the beginning. Okay. So we're looking at example 1, and this is on page 55. Okay, this is example 1. So the question says solve for x and y. Okay, write this down. Okay, so solve for x and y. You got x plus 2y equals 5 and x minus y is equal to the equal. Okay, so there are two equations. We call this equation 1, and this will definitely be equation. Okay, so what we do is we make either in equation 1 or in equation 2. We make either x the subject of the formula or y the subject of the formula. Okay? And you'll see now why we are doing that. So what I'm going to do is I'm going to take from equation 1 and make x the subject of the formula. From equation 1, we have x is equal to, I make x the subject of the formula, what would it be? X is equal to minus 2y plus 5. And this will now become equation. If this is equation 1, equation 2, what will this now become? Equation 3. Okay. So what do we do now? We're going to substitute. Equation 3, can you see this? The x value is 2, negative 2y plus 5. We're going to substitute equation 3 into equation 2. We won't substitute it into equation 1 because it's derived from equation 1. If I formed equation 3 from equation 2, then I would have substituted equation 3 into equation 1. Does it make sense? We substituted in the equation that we haven't used, or the equation 3 is not derived from. Does it make sense? So what is it now? Therefore, x is going to be minus 2y plus 5 minus y equals negative 1. Okay. Now I want you guys to solve for y now. You see there's one unknown here in this equation now. So do that quickly. Solve for y. So what is it now? Negative 2y minus y is equal to negative 1 minus 5. We have negative 6 equal to negative 3y. Divide by negative 3 both sides, therefore y is equal to? Have I answered the question? They asked you to calculate x and y. Not so. So we need to solve for x still. So I can substitute y is equal to 2 either into equation 1 or equation 2 or equation 3. Why? Because I all have x here. But which one do you think I'm going to substitute it in? y2. y1. I would go with 3. Why do you think I would go with 3? Because there we already have x is equal to something. You see, x is already the subject of the formula. Otherwise, if I substitute into equation 1, then I must still calculate x I must still solve the equation having x or isolating the x. Can you see that? However, in equation 3, x is already isolated. X is already the subject of the formula. Do you guys understand? So what we're going to do is, we're going to substitute. And I will substitute y is equal to 2 into equation 3. So what is it going to read now? X is equal to? X is equal to what? Negative 2 into 2 plus 5. So what's negative 2 times 2 plus 5? Negative 4 plus 5 is 1. So there I have solved for x and 1. Okay, and it can be tested. How can we test it? Remember, x is 1 and y is 2. Okay? If I substitute, if I say x are 1 and y are 2, then this would be 1 plus 2 times 2. What is 2 times 2? 4. 4 plus 1 is 5. You see it works? Let's see on the equation 2. X is 1 minus y is 2. What's 1 minus 2? Negative 1. The left hand side is equal to the right hand side. And that is a way to check if this is correct. The sum is worth 4 or 5 marks in your exam. Okay? When it comes to grade 11 and 12, the simultaneous equation is worth 6 or 7 marks. Okay? It's very, very important to understand this concept. Okay? Any confusion here, people? Alright, let's do another one. We're going to look at example 2. And this on page 86. Yeah, they ask you to use elimination method, but we are going to use the substitution method, okay? Write this down. Okay, so where do we start off? Start off by labeling this equation 1, and this one is equation 2. Okay. So here I can either make x or y the subject of the formula. Okay. Or I can work from equation 1 or equation 2. Since all of these have coefficients other than 1 in front of x or y. Can you see that? Say for argument's sake, this was 3x plus y is equal to 2. And 5x minus 2y is equal to negative 18. If that was the equation, then I would have made in equation 1 y the subject of the formula. The reason for that is because there's a coefficient of 1 in front of 1. We got the coefficient of 1 there. Then it would have saved us from working with fractions. You guys understand? It would have saved us from working with fractions. But because you got coefficients in front of all of them, I'm going to work with fractions. So let's go with that. So from equation 1, I'm going to make y the subject of the formula. Okay, I could have made x, but the y is going to be easier for simplifying to make y the subject of the formula. So make y the subject. You got y as the subject of the formula now? Yes. So what do we have? 2y equals negative 3x plus 2. Is y the subject of the formula? No. What do I do next? Divide by 2 both sides. That cancels. So y is equal to negative 3x plus 2 over 2. And this equation 3. So what do I do now? What do I do now? Substitute equation 3 into equation 2. Substitute equation 3 into equation 2. So wherever I see a y in equation 2, I replace it with 3x plus 2 over 2. So what's going to read now? It's going to be 5x minus 2 open brackets negative 3x plus 2 over 2 equals negative 18. So what do I do now? Multiply, simplify. Not so? So you all agree that this 2 cancels that 2 there. Now we'll multiply the negative in. So multiply the negative in everything. So what do we get? 5x plus 3x minus 2 is equal to negative 18. So you solve for x and x is equal to negative 2. So you got 8x is equal to negative 16 divided by 8x is equal to negative. Ever done the job? No. They asked you to calculate x and y. So what do I do now? When you substitute, x is equal to negative 2 into equation 3. Why into equation 3? Because there we already have y as the subject of this one. You guys understand? If we look at equation 1 and 2, you'll see the you must make still y the subject of your formula there. Okay? So what do we have? Y is equal to negative 3 times negative 2 plus 2 over 2. So this is positive 6 here. What's positive 6 plus 2? 8. And 8 divided by 2 is? And we can test it with, again, if x is negative 2 and y is, x is negative 2 and y was 2, no? 4. We can see here, it's 3 times x which is negative 2 plus 2 times 4. That's going to be negative 6 plus 8 which is 2, which makes that good. Can you see that? You see for equation, let's test on equation 2. And equation 2 is going to be 5 times negative 2 minus 2 times negative 4. It's negative 10 plus 8. No, it's positive. Negative 10 minus 8, which is negative 18, which makes that clear. You see that, people? And the sum would have been worth 5 marks. Okay. Let's do another one. Is there any confusion here, people? Any confusion? No? Look at the third example. I think I must teach you the elimination method as well, so you can decide which one you can use. Okay. So I just remembered now that at university you need the elimination method, because there's more than two variables they're eliminating. I mean, more than two variables they work with. Okay. And the substitution method is very difficult to do that particular operation. Okay, we're solving that particular equation. So I'm going to show you how to do the elimination method as well. Okay. But as I said, you guys can decide which one of the two you're going to use. But substitution is used in grade 11. Okay. So I'm going to do the elimination method. Okay. So the question is, solve the system of equations. You got 2x minus 3y is equal to 10, and 4x plus 5y equals 42. So in elimination method, okay, the first step is we need to make the coefficients the same. Okay, so we start off, as you can see, this is already labeled as equation 1 and equation 2. Okay. Then we make the coefficients the same. Okay, so as you can see, for x you got 2x and a 4x. Is this coefficient the same here? We got 3y and 5y. Are those coefficients the same? No. But if we want to eliminate the x, say we want to eliminate the x, okay, then for that coefficients to be the same, what is the LCM between 2 and 4? The LCM, 4. Not so? So from equation 1, I'll multiply this by 2. If I multiply this by 2, what do I get? 4x minus 6y equals 20. You all agree that that equation, there is still the same equation. If I divide throughout by 2, I'll get the equation 1 again. Not so? Do I need to multiply anything by equation 2? No. So that remains 4x plus 5y equals 42. Okay. So what you're going to do now is, this is now equation 3, and of course this is still equation 2. So you're going to say subtract equation 2 from equation 3. Subtract equation 2 from equation 3. If we do that, Rebecca follows from me right first, so that's first is. So what's 4x minus 4x? 0, that cancels. And that is what I want. Okay? What is negative 6y minus 5y? Negative 11y. What is 20 minus 42? Check on your calculator. 20 minus 42. Negative 22. Yes? Remember what we're doing? We're subtracting equation 2 from equation 3. So equation 3 is 4x minus equation 2. There's like a minus in front here. Multiply the negative out, this goes negative, negative, negative. You see that? So 4x minus 4x cancel. Negative 6y minus 5y. It's negative 11y. 20 minus 42. It's negative 22. Where's the confusion? Where's the confusion, people? Well, with the signs here. That's why I said subtract. In the next example, you're going to see I'm going to add. Okay. But for now, it's a subtract. Why do I subtract? So that I can eliminate the x. That's why I'm subtracting. You guys understand? So, how do we get y on its own? Divide by negative 11 both sides. So y is equal to 2. Have I done the job? No. So what I need to do is, I'm going to substitute that. y is equal to 2 into equation 1. I could have substituted anywhere in equation 1, 2 or 3. Because right now I don't have x as the subject of the formula. You guys understand? So let's substitute. Y is equal to 2 into equation 1. Because into equation 1 it's going to now read the equation 1 is now going to read 2x minus 3 times 2 equals 10. So it's 2x is equal to, what is negative 3 times 2? Negative 6. Take that over, becomes 10 plus 6, which is 16. Divided by 2 both sides. So x equal to, and of course you now know how to test. Okay? You all understand? Let's see what would have happened if I eliminated the y. Okay? If I eliminated the y. Well, how would I have eliminated the y? As you got already, the equation 1 and equation 2 is marked out already. Okay. So what would the LCM for the what's the coefficient of the y's? Is 3 and 5. Not so. So what is the lowest common multiple between 3 and 5? 15. So the first line must be multiplied by what? 5. Y by 5, so that I can get 15 in front of y. Make sense? Okay? So if you multiply this by 5, what do I get? 10x minus 15y equals 50. Okay? This here must be multiplied by what? Times by 3. So what do I get? 12x. Remember, multiply each number by 3. Yeah? 12x plus 15y equals 42 times 3 is 126. Okay? You all agree with that? Now, in the previous question, or in the previous attempt, I eliminated the x by subtracting the 2. But if I'm going to subtract here, remember this is now equation 3 and this would now be equation 4. If I'm going to subtract equation 3 from equation 4, then what's going to happen? So it will become 12x minus 10x. 15y minus 15y. So by subtracting, I wouldn't have eliminated a variable. Can you see that? So what am I going to do here? I'm going to add it. If we add, then it's going to be negative 15y plus 15y will cancel. Make sense? So we're going to say we're going to add equation 3 and equation 4. So what is 10x plus 12x? 22x. What is negative 15y plus 15y? Cancel. And that's what I want. I want to eliminate. That is why it's called elimination. Okay? Is to eliminate. Which is equal to 50 plus 176. So if I divide by 2 both sides, 22, sorry. So x is equal to 8. Okay. That's what I got idea. Yes. Yes. Then, what do I do with it? How do I calculate y? You substitute x is equal to 8 into equation 1. Substitute x is equal to 8 into equation 1. Substitute x equal to 8 into equation 1. So what would it read now? 2 times 8 minus 3y is equal to 10. It's going to give you 16, not so. So it's minus 3y is equal to 10 minus 16, which is negative 6. So y is equal to 2. Okay. So you guys can do any method, either substitution or the elimination method. Okay, any confusion here? Any questions? Right, for homework I would like you guys to do exercise 4.9. You do for me number 1, number 2, A, C, E, G, I, and K. That is every alternate sum. Let's say it again. Number 1, number 2, A, C, E, G, I, and K. Okay. Your next heading, problems leading to linear equations. Problems leading to linear equations. Now you guys have dealt with word problems before, not so? You've dealt with word problems since primary school. You've formed equations since grade 8, not so? Many of which you did in grade 9 as well. The problems leading to linear equations. Word problems can be represented by equation and then easily solved. Okay. So the idea is to set up an equation. Once the equation is set up, you can solve the equation. Not so? Then we are told we must be able to translate word statements into mathematical notation. That is your equation basically. The table gives some examples of statements written in mathematical notation. This is on page. What page are we on, people? Okay, so you're on page 89. So here number increased by 5. Just take it off. Just get this here. Right, so we're on page 89. We are told a number increased by 5. What would that be? X plus 5. Okay? So that's your mathematical notation for the sum in words. Yes, Michael? Your finger was up? Wasn't it up? My glasses must be light. A number decreased by 5? X minus 5. 5 more than a number? 5 more than a number. 5 plus x, or x plus 5. No? The next one? 5 less than a number. X minus 5. It says here 5 less than a number. So it's a number, 5 less than that, which is x minus 5. You all agree with that? Okay? You confused? You agree? Yes. Okay. 5 times a number. 5x. Okay, that one's easy. 5 times x, so 5x. 3 consecutive natural numbers. What is consecutive? 1 following the other. Okay. So the first number is 8. The next one is going to be? Then? The first number is 57. 199. So what happens is we're just adding 1 all the time. So the first number is x. And what's the next number? X plus 1. Then? X plus 2. Okay. An even number. 2. That is a even number. An even number. But in general terms, an even number would be x plus 2. Now what if x is 3? 3 plus 2 is 5. X. But if x is 1, or if x is 3, it's odd.
Why don't you say odd number?
Say odd number. But the question says an even number. Okay, so give me examples of even numbers. 2, 4, 6, 8, and so on. So each number is a multiple of, or as a factor of 2. So what we do is, whatever x is, x could be odd or even. But I need to multiply it by 2. Why? So in case it is odd, it will always result in an even number. So choose a value for x. 5. What's 2 times 5? 10. Is that not even?
Yes.
Choose another value for x. 4. 2 times 4? 8. Is 8 even? Yes. So by saying 2x, that means to say it will then always be even. You guys understand? An odd number. An odd number. Huh? 3. Yes, 3 is odd. But in general, in algebraic terms.
So I just like divide.
Sorry? Divide. Okay, how will we get an odd number? If I just put an x there, then that x can be odd or even, not something. If I multiply the number by 2, the number will always be even. Now the odd number, a number is either odd or even. So what happens when I move from one number to the next? I just add 1 all the time. So if you're going to say it's going to be 2x plus 1, 1. Can you see that? Because an even number plus an odd number will always be odd. Not so? So an even number, a number that's always even plus 1, which is odd, will always be odd. Okay. The perimeter of the rectangle, x meters by y meters. So you got the rectangle. If you got your length is x and your breadth is y. So what will the perimeter be? 2x. Okay, that one was easy. Nice. Let's check if there's more. Okay. Yes? Yes. A means 1. You might take 3. Three people crying. Okay. The value in a rands of x 50-cent pieces and y 2 rand coins. The value in a rands of x 50-cent pieces and y 2 rand coins. Okay, let's put this in terms of numbers. If x was 3 or 4 and y was 2, then how much, what would the value in the rands be? The rands you would have 4 50 cents, not so? Plus 2 rands. So that would be 2 rand plus 4, which is 6 rand. 8. Holidays seem not to be good for you, no? Right, let's change it up. Let's say this was 8 and this was 6, so 5. What would that have been in a rand? It's going to be 5 times, sorry, not 5. Yeah, it's going to be 8 times 50. Why don't you 0.5? It's half a rand, not so. I can't have rands here and cents there. That's not going to make sense. Okay. So that's plus 5 times 2 rand, which is 4 plus 10, which is 14. Now what if they have an x here and a y there? What would that be? Your what's the name in the range would be x times 0.5 plus 2 times 1. So in other words, a half x plus 2y, or 0.5x plus 2. Does it make sense? Okay. Why you guys know? Whoa. Okay. The numerical value of a 2-digit number with tens x and units y. Okay, so let's put that in terms of numbers. If this was a 2 and that was a 3. a numerical value of a 2-digit number whose 10th digit is 2 and the units digit is 3. So what number would that be? 23. No? If this was 8 and this was 7, what would that be? 87. But if that's your x and a y, what would that be? X times 10. Right? You looked at the answers? No? Nice. So this here could have been written as 2 tenths and 3 units. Not so. That was 8 tenths and 7 units. So if you got an x times 10 plus y times 1. So it's going to be 10x plus 1. That's correct. Nice. I'll spot it there. The x tenths and the time taken to run a 10 meter, time taken to run 100 meters at x meters per second. So how do you work out time? So there's DST, no? Is that correct? Yeah. Right, you want to calculate the time. So T is equal to D over S. So your distance, so 100 meters over x meters per second, 100 over x. Okay, you guys got it? The next one, the unit cost of x items if the total cost is y rands. How do you work out if it was the unit cost of 10 items if the total is 80 rand, for argument's sake? How do you work out cost per unit? Cost per unit, you're going to say 80 divided by 10, which is 8 rand. So here we have x and y, so it's going to be y over. Okay, any confusion there? Okay, that is the basics of setting up your mathematical notation there. Alright, so the bell is going to ring soon. So for homework I want you guys to do exercise 4.10. So I'm not going to give you the whole exercise in 4.10 for homework. I just want you guys to do the first 5. Exercise 4.10, the first 5 sums. Okay. And it's on page which page is this on, people? Okay, another bell is going to ring soon, so let's just look at one example before that. Okay, we'll do it tomorrow.
People enjoy the rest of your day. Good morning, class.